In May 2024, a spectacular multicolored light show flooded the skies across the world. These displays are known as the auroras. They're usually seen near the polar regions, but that May, skywatchers spotted the glowing lights far from Earth's poles. People were witnessing the biggest geomagnetic storm in over 20 years.
This storm was so intense. It was the most intense in 2 decades. This was one of those large events that we've been talking about for years.
It all began from this active region on the sun. Active regions are known for having intense magnetic fields, and the more tangled those fields become, the more likely they are to erupt.
We watched the active region evolve, and we thought that this might be something to watch and might be something active.
Eventually, the active region unleashed a chain of huge solar eruptions directly towards us.
What made it so strong was the fact that there was so much energy put off by the sun. It was really great conditions for the perfect storm.
On May 10th, the eruptions reached Earth, triggering a global disruption to Earth's magnetic field, known as a geomagnetic storm. It was rated a G5, the rarest and strongest type. The powerful storm pushed auroras to appear in unusual places like Arizona in the United States and Perth in Australia.
That energy interacted with the Earth and created the aurora and caused all sorts of disturbances that we felt here on the ground.
The storm caused some high voltage lines to trip and transformers to overheat. GPS-guided tractors also veered off course, further disrupting crucial planting time that had already been delayed by heavy rains that spring. In the air, transatlantic flights rerouted due to risks of high radiation exposure and communication and navigation disruptions. Farther up, NASA's Goddard spacecraft saw Earth's upper atmosphere get unusually hot. The temperature 100 miles up in the thermosphere usually peaks at 1,200 degrees Fahrenheit, but during the storm, it reached 2,100 degrees Fahrenheit. The heating caused the atmosphere to expand, which affected satellites.
There were thousands of satellites that had to move their orbits because the storm was coming through.
The storm also affected the space beyond Earth. It created 2 new temporary belts of energetic particles around our planet, adding to Earth's 2 permanent ones, which are known as the Van Allen radiation belts. The particles in these belts can harm orbiting satellites and astronauts heading for deep space, so NASA studies them closely. As the sun rotated, the active region eventually moved away from Earth and redirected its outbursts towards Mars. On Mars, NASA's Curiosity rover saw solar particles from the storm. The rover also recorded the biggest surge of radiation since it landed in 2012. If an astronaut had been on the Martian surface, they would have received a radiation dose equivalent to 30 chest X-rays at once. With spacecraft throughout the solar system and modern cameras in so many people's pockets, the storm was the most well-documented in history.
There's lots of data. We're able to actually use that data to understand things and predict more and more how this is going to affect our Earth.
Although the storm passed within days, NASA will continue to learn from the observations for years to come, helping us better prepare for the next big storm.